This is AI Biz Stories. Real business history. Told through the decisions that built empires and the ones that destroyed them. Today's story shows how one company quietly became the most powerful force behind artificial intelligence. In the mid-20s, NVIDIA was a gaming company. Outside PC enthusiasts, almost nobody cared. But by the early 20s, it had become one of the most important technology suppliers on Earth. Its chips powered the artificial intelligence models, rewriting entire industries. Cloud providers fought for GPUs. Startups hoarded them like gold. Black market brokers emerged during global chip shortages. And in 2023, NVIDIA crossed a $1 trillion valuation, faster than almost any hardware company in history. This is the story of how a graphics chip maker became the engine of artificial intelligence, and how its founder bet everything on a future almost no one else believed in. The story begins in 1993, inside a small diner in Silicon Valley. Jensen Huang sits down with Chris Malachowski and Curtis Priem. Their idea? Build chips optimized for graphics, a niche market the industry giants largely ignored. Huang saw something others missed. He believed video games would become the world's biggest entertainment industry. Interactive, immersive, and brutally demanding in terms of computation. The early years were brutal. Competitors like 3DFX and ATI dominated the charts. NVIDIA stumbled, relaunched, and fought for survival. Then, in 1999, NVIDIA released the GeForce 256, the world's first GPU. It was more than a graphics card. It was a programmable parallel computing engine. Gamers embraced it. Developers followed. NVIDIA had found its identity, a company built on parallel processing, a foundation that would soon collide with a breakthrough far beyond gaming. In 2006, NVIDIA launched something that looked almost unnecessary, a software platform called CUDA. The idea was radical. Let developers use GPUs, not just for graphics, but for general-purpose computing. Most executives didn't see the point. The market wasn't asking for it. But Jensen Huang insisted. He believed GPUs could accelerate physics, simulations, scientific workloads, everything that strained traditional CPUs. CUDA allowed programmers to tap into thousands of GPU cores using familiar tools and languages. For years, it looked like an expensive science experiment with no clear payoff. But underneath, it was building something priceless, a developer ecosystem inherently tied to NVIDIA hardware. When researchers needed raw performance, CUDA was already there, the fastest, most mature path. This obscure decision would become NVIDIA's masterstroke. In 2012, deep learning exploded onto the global stage. Geoffrey Hinton's team won the ImageNet competition with AlexNet, a neural network trained on 2 NVIDIA GPUs. The signal was impossible to ignore. Neural networks needed GPU acceleration. Suddenly, every serious AI lab required NVIDIA hardware, and almost every researcher used CUDA. NVIDIA had already invested in data center-grade GPUs and high-speed interconnects. The Tesla K80, then the V100, then the A100. Each generation pushed AI performance to new extremes. By 2023, NVIDIA's H100 became the heart of the global AI boom. Cloud providers like AWS, Google Cloud, and Microsoft Azure pre-ordered tens of thousands. Training frontier models required entire clusters of H100s working together. Then came Blackwell, announced in 2024, designed for trillion-parameter models. It was not just a chip. It was the foundation of an AI-driven economy. AI didn't just benefit NVIDIA. AI required NVIDIA. But dominance always attracts challengers. AMD launched its Instinct MI300 accelerators. Intel tried a comeback with Gaudi. Google expanded its tensor processing units, TPUs, optimized for its own AI workloads. Meta explored custom silicon. Tesla built its Dojo supercomputer. Meanwhile, geopolitics reshaped the race. The United States restricted sales of high-end NVIDIA GPUs to China, aiming to slow foreign military AI development. China accelerated domestic chip programs in response, pushing companies like Huawei and Beren to build local alternatives. But none matched NVIDIA's core advantage. Rivals had hardware. NVIDIA had hardware and the platform. CUDA had become the industry standard. Developers were trained on it. Startups were built around it. Data centers were architected for it. This wasn't just a hardware battle. It was a platform war. And NVIDIA was leading it by almost a decade. By the mid-20s, the world's largest companies depended on NVIDIA. OpenAI used massive GPU clusters to train models like GPT-4 and GPT-5. Meta expanded its infrastructure to tens of thousands of H100s. Tesla trained its autonomy networks on NVIDIA hardware before moving to its own chips. Amazon, Microsoft, and Google invested billions in GPU superclusters just to keep up with AI demand. Across the startup world, from robotics to biotech to finance, companies could not operate at the cutting edge without NVIDIA GPUs. A single H100 sold for tens of thousands of dollars. A full training cluster could cost hundreds of millions. NVIDIA was no longer just a chip vendor. It was the backbone of modern intelligence. The most strategic supplier in the world. An empire powering the AI revolution. NVIDIA's rise was not an accident. It came from three defining choices: betting early on parallel computing, building CUDA before anyone cared, and positioning the company at the intersection of gaming, high-performance computing, and artificial intelligence. The lesson is clear. Platforms win, ecosystems scale, and timing, when combined with conviction, can reshape entire industries. AI will only grow more powerful. The companies building the future will either run on NVIDIA or fight to escape its gravitational pull. NVIDIA didn't just take over the world, it built the processors that taught the world to think. If you found this story valuable, consider liking the video and subscribing to AI Biz Stories. It helps the channel grow and allows us to create more in-depth business documentaries like this one. Thanks for watching.